When you're trying to solve a rational or polynomial inequality, first thing you need to do is compare the expression to 0. So we have that already set right here. It's greater than 0. Next, you're going to factor the numerator and denominator. So if we factor the numerator, we get x minus 7 and x minus 2. We factor the denominator, we get x plus 7 and x minus 4. So that's all greater than 0. So we've written this now in its factored form. So think about what each of these factors represent. So here in the denominators, each of these is the vertical asymptote. So we know at -7 and at +4, we have vertical asymptotes. And up top, we have factors when you set equal to 0 are x-intercepts. So here we have the x-intercepts at 7 and 2. So this gives us 4 critical points. So we have 7, 2, 4, and -7. So what we're going to do is we're going to take a look at those critical points. And so when I mark them, I have 4 critical points on a number line. I'm going to go from left to right. So the lowest number is -7, then 2, then 4, and then 7. So there are my critical points. So with the -7 and the 4, we have these open dots. Remember, these are vertical asymptotes. So when we look at the graph of this, the graph will have asymptotes here. And technically, the 7 and the 2 are going to be closed dots. These are our x-intercepts. So keep in mind what we're looking at here is that if 2 and 7, if this had been a greater than or equal to, then those closed dots are going to be represented using brackets in our interval notation. But because it's a greater than, there is no inclusion. This is not included. We know that it's only going to be the parentheses for that. I'll talk about that when we get to that point. All right, the next step, once we find our critical points, is we're now going to evaluate each of the intervals that are formed by these critical points. So to do that, what we're going to do is take each of the factors that we have over here on the left side of our inequality, and we're going to just stack those vertically. So I tend to move from left to right. So I'm going to start with the factor that coincides with with a -7, which is our factor x plus 7. And then we have the next x minus 2. We then have x minus 4, and we have x minus 7. So there's all my factors that form my rational expression, all just vertically stacked. And the reason I evaluate these individually is it's much easier for me to see that in these intervals of critical points here, anything to the left of -7, when you plug it into this factor, is a negative number. Anything to the right of it, whether it's in the interval here, 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 or here, anything to the right of -7 is always going to give me a positive number. So I'm going to do the same thing with each factor. So from 2, everything to the left of 2 is negative, everything to the right of 2 is positive. So I just fill those signs in each of the intervals that are formed between the critical points. So everything to the left of 4 is negative, everything to the right is positive. Everything to the left of 7 is negative, and everything to the right is positive. So I write them in this order because it's just really easy to manage in this regard. You don't even have to think about it. Next, what we're going to do is test the overall sign in the interval. So this is going to tell us what the graph looks like. So as we look down this 4 positives multiplied by each other, again, each one representing the sign of a factor, gives you an overall sign that's positive. So any number greater than 7 is going to be in the positive of our graph. In the next interval, we have 1 negative times 4 or 3 positives. So that's going to be an overall sign of negative. In the next interval, negative times a negative is a positive times 2 more positives means that's positive. Negative times a negative times a negative, we get a negative times a positive, means the overall interval here is negative. And then finally, 4 negatives give us an overall sign that's positive. So what this is telling us here is that we know our graph is going to be positive in this interval. It's going to be negative in this interval. It's going to pass through 2 and then switch to positive in this interval. It's going to be negative in this interval, and then it's going to be positive in this interval. Now, I've written this because I've already kind of peeked at what the graph looks like. It's not a bad idea to see what that graph is. But here is our graph of that, and you see that on the far right here, you have the positives, you have negatives switching to positive at the 2, you have a negative switching to positive at the 7. So that's what our actual graph looks like in our the model that we used to just evaluate the signs in each interval gives us a pretty good glimpse into that. So the final step in this problem is to actually answer the question. The question is asking, where is this greater than 0? So we're looking for the positives. So our answer is going to be in these intervals where we get a positive number. And so we just use interval notation to represent that. Now, this is where the inequality comes into play. Since this is not included, everything's a parentheses. So we see that it's positive from negative infinity to negative 7. So that's one interval that it's positive. We also see from 2 to 4, it's positive. Now, if this had been a greater than or equal to, then this would have been a bracket here instead. But because it's just the greater than, we leave it as a parentheses. And then finally, the last interval that's positive is 7 to infinity. And so we use union of sets to connect those. And so that would be our overall answer, where it gives you all of the values for which this expression is positive, which is here, here, and here.